So on to problem 15 of the MIT Integration Big Qualifying Exam 2015. This is actually a very interesting problem. It is the definite integral of from x equals to 0 to x equals to 4 of the absolute value of x minus 1 over absolute value of x minus 2 plus the absolute value of x minus 3. So this is actually interesting, and it kind of tests us on what we know about absolute values. So let's see how we may be able to solve this. So this is our problem. X equals to 0 to 4, integrating absolute value of x minus 1 over absolute value of x minus 2 plus absolute value of x minus 3. Right. So what is the absolute values of the function f(x)? So this is equal to f(x) when f(x) is greater than 0. Let's say greater or equal to 0, or when f(x) is less than 0. That's what it means. So with this in mind, we see that x minus 1, x minus 2, x minus 3 have phases for which they are negative. And so that means we have to split our integral into 3 phases, because between 0 and 1, everything x minus 1, x minus 2, x minus 3, they're all negative. So what we do in this domain, we flip it. Negative of x minus 1 is 1 minus x. Negative of x minus 2 is 2 minus x. Negative of x minus 3 is 3 minus x. Plus, from 1 to 2, x minus 1 is positive in that domain, so f(x) remains, but x minus 2 is negative, so we have negative of x minus 2, we get x 2 minus x. X minus 3 is negative, so we have 3 minus x. And then from 2 to 3, x minus 1 is positive, so it remains. X minus 2 is positive, so that remains. But x minus 3 is negative, so we still have 3 minus x. Plus, from 3 to 4, everything is positive, so we have x minus 1, x minus 2, plus x minus 3. So what we see here is this and that cancel, and negative 2 plus 3 is 1, so we just have the integral of x minus 1 here. What does our integral become? It becomes from 0 to 1, we have 1 minus x over 5 minus 2x. Plus 1 to 2, we have x minus 1 over 5 minus 2x. 2 to 3, we only have x minus 1. And 3 to 4, we have x minus 1 over 2x minus 5. Okay, so very interesting. What we see here is that this and this are very similar, only that this part here is the negative of the first one. So we can take advantage of the long division here, since we have 1 minus x and we have 5 minus 2x multiplied by half. We have 5 over 2 minus x, 0 here, and here 1 minus 5 over 2 is negative 3 over 2. So this expression 1 minus x over 5 minus 2x equals to a half minus 3 over 2 times 1 over 5 minus 2x, and x minus 1 over 5 minus 2x equals to negative a half plus 3 over 2, 1 over 5 minus 2x. We could as well also look at this fraction here. It's easy to see that this over 2x minus 5 is a half plus 3 over 2, 1 over 2x minus 5. So we have three fractions, 1, 2, and 3. Okay, so our integral now becomes integral from 0 to 1 over half minus 3 over 2, 1, 5 minus 2x plus from 1 to 2 negative a half plus 3 over 2, 1 over 5 minus 2x plus 2 to 3 of x minus 1 plus 3 to 4 of a half plus 3 over 2, 1 over 2x minus 5. Okay, so which is equals to a half, so we're solving for this, a half x minus 3 over 2 in bracket negative a half of 5 minus 2x natural log 0 to 1. This, okay, plus I may just use the curly bracket. We have negative a half, not the curly but square bracket, plus 3 over 2 negative a half we'll remove 5 minus 2x 1 to 2 plus x squared over 2 minus x 2 to 3, and we have a half plus 3 over 2 half natural logarithm of 2x minus 5 3 to 4. Okay, maybe we may want to just clean up this a little bit and maybe just write it nicely, something like that. Okay. Let's try to our next panel just to make things clear. So we have a half x plus 3/4 natural logarithm of 5 minus 2x 0, 1 plus negative a half x minus 3 over 4 log of 5 minus 2x 1 to 2 plus x squared over 2 minus x 2 to 3 plus a half x plus 3/4 natural logarithm of 2x minus 5 3 to 4. So looking at that part there, we get upper limit a half plus 3 over 4 natural logarithm of 5 minus 2, we have 3 minus 0 half plus 3 over 4 log of 5 minus 0 is 5 plus negative a half times 2, so that becomes 1 negative 1 minus 3 over 4 5
I set your alarm for 4 a.m.
3 over 4 5 minus 2x, this becomes log 1, and this usually tends to 0, log of 1 minus negative a half times 1, which is negative a half, minus 3 over 4 times log of 5 minus 2, which is log of 3. Okay, plus, now onto this we have 3 squared over 9. We can just maybe just say, okay, that's 9 over 2 minus 3 minus 2 squared over 2 is 2 minus 2, this cancels, plus 4 over 2 becomes 2 plus 3 over 4 log of 8 minus 5 is 3 minus 3 over 2 plus 3 over 4, 6 minus 5 is 1, so log of 1, this goes to 0. And so we're going to pick out our constant, so we have this, a half, and then we have this negative a half interacting, because we have negative here, it's positive a half minus, so that's negative a half, so we have a half minus a half. This negative a half comes from this positive a half interacting with this negative a half, and then we have 9 over 2 minus 3, that is 9 over 2 minus 6, that's 9 minus 6 over 2, which is 3 over 2, so we have 3 over 2 coming from here, and then we have positive 2 coming from here, and then we have 3 over 2 negative coming from here. So what do we see? This and that would cancel, this and that would cancel, so we're left with positive 2 there. Then we have 3 over 4 log 3 coming from here, and then we have this negative and this negative this becomes positive, another 3 over 4 log 3. And then we have this 3 over 4 log 3. Okay, there are how many? There are 3. 1, 2, 3. And then we have this minus 3 over 4 log 5. So we've been able to account for that, account for that, account for that, and we've been able to account for that. Okay, so this is 2 plus 3 times 3 over 4 log 3 minus 3 over 4 log 5. And so what we've come to find is that the integral from 0 to 4 of absolute value of x minus 1 over absolute value of x minus 2 plus x minus 3 absolute value, this becomes 2 plus 3 times 3 over 4 is 9 over 4 log 3 minus 3 over 4 log 5. And that, ladies and gentlemen, is our answer.